In this video, we are going to go over how to use MATLAB as a calculator. So similar to how we type in our equations into a calculator, typically a graphing calculator, is how we're going to type in our equations here in our command window. When we're typing our equations in our command window, something to remember is, and I'm going to take some notes here in the command window, the way that I can take a note is by putting a percentage sign. So a percent sign means that I am taking a note. I'll use this when I start creating scripts to leave myself notes to help me follow along in my code. So I'm just putting a little percent sign, and that means that this is a comment or a note for myself, and that the program, that MATLAB, is not going to run that line. So something to note is that spaces typically don't change what we're typing. So for instance, we could type 1 plus 3, enter, and get the answer of 4, or we could type 1 space plus space 3, enter, and we get 4. You see, when we use MATLAB as a calculator and we don't specify a variable name, our default variable name is ANS, answer, and we see that that is now stored over here in our workspace. But I wanted to first show you that spaces rarely change the meaning of our code. The only time spaces are going to change the meaning of our code is when we're within square brackets, which we will see later on in this class. So when we're in square brackets, and spaces sometimes mean something, which we'll see, and sometimes they don't. So let's talk about using MATLAB as a calculator. So here we've just done some simple arithmetic. If instead of storing our answer in ANS and we want to store our answer in a variable, we can type the name of that variable, let's say x, and then what we want to store in x. X equals 5 times 9 squared, which is 405. And now we see that 405 is stored in x. So some rules for variable names. So first I'm going to type CLC to clear this screen, clear my command window. CLC will clear my command window, but not my workspace. If I wanted to clear my workspace, I would type in clear. So clear, the word clear clears our workspace. CLC clears our command window. So let's talk about some rules for variable names. So first of all, a variable name is basically what we're going to store some value or some matrix, some vector within a variable. So our variable names can only contain letters, numbers, and underscores. So no exclamation points, no question marks, only letters, numbers, and underscores. Another rule for our variable names is that the first character must be a letter. So we cannot start our variable name with an underscore or a number. We must have a letter to start our variable name. Our next rule, which I don't recommend testing this rule, but the max length of our variable name is 255 characters. That's a really, really long variable name. So I don't recommend having variable names that long. But anyway, you also can't have any spaces in your variable name. our variable names are case sensitive, which means lowercase x is not capital X. Those are two different things. This is a very, very common error that I see in people's codes. Once we start writing our codes, is you'll have a lowercase x at one point in your code and a capital X at a different point in your code, and you'll wonder why your code isn't working. And it's typically because your cases are off. Lastly, you can use the name of an existing function. So you can call your variable name cosine or sine, but you should not. Because as soon as you call your variable name cos, which is cosine, that means that you can no longer use the function cos until you clear your workspace. So you could type cos equals 1, but now we can no longer use our variable name, we can no longer use the function cosine until we type clear to clear our workspace, and now we can use that function. So a function is just a code that is stored that performs some operation. So a code that is stored that performs some operation. For example, cos takes the cosine of a number. We will also be writing our own functions, but MATLAB has a lot of built-in functions. So examples are sine, cosine, min, max, determinant, exponent, logarithm. So let's kind of practice typing out some equations here. So I'm going to type CLC to clear my command window. And I'm going to type x is equal to, we can say pi, pi. And we see that x is equal to 3.1416. The way that I have my formatting right now, I'm only seeing 4 digits behind the decimal point. If I wanted to change that, I could type in format long, format space long. And now I'm going to retype in x is equal to pi, and I see I get 3.1415926 and so on. And it does go out to more decimal points than that, but format long is just going to show you this many. I'm going to go back to format short just because I like how it looks better. So format space short, enter, to keep it at just 4 decimal points. So x is pi. So I can take, remember CLC just clears my command window, not my workspace. So I can take the cosine of x, and that's going to be -1. This tells me that the function cosine takes the angle in radians. If I didn't know that, let's say I knew that cos is a function, but I'm not quite sure how to use it, MATLAB has a built-in help function. So the way that we use MATLAB help is we type in the word help and then space and then whatever function we're using, cos. And it says cosine of an argument in radians, and cosine of x is the cosine of the elements of x. And then it says see also a cosine and cosine d. So a cosine, if I click on this, is the inverse cosine, where our result is in radians. Cosine d, I'm just clicking here, is the cosine of an argument in degrees. And a cosine d is the inverse cosine where our result is in degrees. So I'm going to do a CLC. So remember that was help, space, and then whatever the function is that we are interested in. if you need more information than what MATLAB is giving you here, that's where Google can help you. So here I've searched MATLAB help cosine. I'm going to go to the MathWorks website. And we get a lot more information about this. So y cosine of x, it tells us about the syntax that we're going to use, a description, as well as giving us some examples. So cosine is a pretty, basic function here, but this is going to be really helpful for future functions. I think you can also access this through MATLAB help. So if you click help right here, this question mark, instead of going to Google and you can search help, you can type in cosine, and it's not giving me what I want. So I'm going to refine by functions. Interesting. Okay, well, I'll have to take a closer look at why this is not showing up under functions. Weird. Okay. I'll take a closer look at that. For now, you can just type it into your command window or go to Google and get a more in-depth description from the MathWorks webpage. Okay, so far we have learned the rules of our variable names. We've learned how to store a number in a variable, and we've learned how to use MATLAB help to find information about a function. Something I want to make clear is when using an equal sign. So an equal sign in math, and an equal sign as most of us know it. So in math, typing the equation x equals 1 means that x is 1. It means x is defined by 1, x is 1. They are the same thing. That is not what it means in programming. So in programming, so in math, x equals 1 means that x is 1. In programming, x equals 1 does not mean that x is 1. It doesn't mean this universal truth that x is 1 like it does in math. In programming, it means store 1, so store the value 1 in the variable x. So if we type x equals 1, and then in our next line say x equals 2, so first we stored 1 in x, and then we stored 2 in x. So that just means that 2 is now stored in the variable x. We don't remember that it was once 1. There's no memory of what was once stored in that variable. So if we say x equals 1, that means store 1 in x. And then I introduced a new thing here, this semicolon. I'll get to that in 1 second. And then if we type x equals 2, that means that we're now storing 2 in x. And x has no memory of once being 1. So this semicolon, we can see the difference between what happened when I put a semicolon and what happened when I didn't put a semicolon. So putting a semicolon suppresses output in our command window as well as in the functions and scripts that we're going to write. So using a semicolon suppresses output in the command window. So our output is still stored in the workspace, but our output is not printed in the command window. So as I should have said this at the very beginning of the video, but as you're watching these videos, I recommend taking notes, especially a lot of the green stuff that I'm writing here, as well as following along with your own computer with MATLAB open. But you should definitely be writing some of this stuff down because we're going to be using this again and again and again. So as I mentioned, on the front page of Canvas, this class is really, really cool because we're going to go through pretty much every math class that most of us are going to take. We're going to go through, algebra. We're going to go through calculus. We're going to go through differential equations, but we're going to learn those classes, or the material in those classes, in a very, very different way than what you learn them in math. So we're going to learn numerical methods to solve ordinary differential equations. So if we think back to one of the first maths that we learned, you might remember the acronym PEMDAS. So PEMDAS is an acronym that reminds us of order of operations. This is very important when we are typing our equations into MATLAB. So PEMDAS, if you remember, stands for parentheses. So first, our code is going to solve anything that's inside parentheses. Next, we have the E for exponent. Next, we're going to solve anything that's to the power of something. Next, we have multiplication and division. So we're going to solve those in the order from left to right that they appear. And then last, we have addition and subtraction. So if we see an equation, let me get a tablet up here. So if we have an algebraic equation like this, let's go over how we would type this into our calculator. So into MATLAB when we're using MATLAB as our calculator. One of the first things that is really important to remember is to put parentheses around the lower part there. Because this is multiplication, we don't need parentheses there, but anytime we have things being added up, we need parentheses. So going into MATLAB, we have, okay, I lost my equation. Let's say that's equal to x, or y. We have y is equal to 2 times, so we have 3 times 4 minus 2 squared divided by, and in parentheses, we have to have that bottom part, 4 plus 6 minus 3 squared. And that's equal to 16. So an area where I often see mistakes in folks' labs are forgetting these parentheses around that bottom portion. In MATLAB, you can certainly add extra parentheses. So I can retype this, and I'm getting kind of tired of typing, but I know I just want to make one small edit to here. Something that I can do is I can use the arrow up key on my keyboard, so arrow up, and I get the last thing that I typed. If I arrow up again, I'm going to get the thing I typed before that, and then arrow up, arrow up, arrow up, and you keep going through all the things that you've typed. So I'm arrowing down to get back to that equation. I can add in some more parentheses that aren't really needed, and then type enter. So more parentheses are fine. You'll note that, so when you're using, say, a graphing calculator like this one, a TI-84, or the TI-83, or the fancier versions, you don't need to close your parentheses when you're using your last parentheses when you're using those calculators. In MATLAB, you absolutely have to close your parentheses. So we've just gone over how to type an equation into MATLAB using PEMDAS, so using our order of operations. We have looked at how to access previous entries by using the up and down arrow. Let's say I know I want this. Let's say I'm going to look at my command history. So let's say I want to go back to this x equals 2. And I don't want to arrow up forever until I get there. But I know the line started with x. I can type in x and then arrow up. And I'm going to get everything in my command history that started with x. So I'm going back through and then I get to x equals pi, and that's the first x that I typed in. If I just type the name of a variable, then it prints out whatever is stored in that variable. If I type in the name of a variable that's not there, so let's say on accident, if I type in capital X, I'm going to get an error that says undefined function or variable capital X. Did you mean lowercase x? Yes, I did. Enter. An undefined function or variable. Oh, interesting. Okay, I'm just going to type CLC. So we had x. Did you mean x? Yes, I did. So I just press enter there. And I get that x right there. So anytime you end up with red, that is an error that MATLAB is showing you. So I think I'm going to end the video there. A challenge for you this week would be to, instead of grabbing a calculator for one of your other assignments, for one of your other classes, to do some calculations here in MATLAB using the command window for your other classes. So let's say you have, a math assignment due this week and you have some calculations to do. I challenge you to, instead of using your calculator, to use MATLAB. It might take a little bit longer this first week, but I think that will really help you kind of moving forward with this class.